A vector upon A. Okay, tell me one thing. Do you know that a vector is actually the magnitude multiplied with the direction? This is a unit vector in the direction of this, and this is the magnitude of height. Now direction cosine. Okay, let's say a vector ax I cap plus ay j cap plus az k cap subtends alpha, beta, gamma angles with the positive direction. This is important.
Okay.
Positive direction of coordinate axis. Coordinate axis. Then cos alpha, cos beta, cos gamma are the direction cosines. Okay.
Yeah.
So actually what happens is ax by a, ay by b, a, az by, these are the direction cosines of this vector. So technically you can say that direction cosines are the three components of a unit vector, a vector upon a. Okay, tell me one thing. Do you know that a vector is actually the magnitude multiplied with the direction? This is a unit vector in the direction of this, and this is the magnitude of this a vector. Right? This is how you write a vector. Okay.
1 second. Yeah. Get done.
Hmm. Mm. Also, I have written that direction cosine are the three components of unit vector of A, which can also be written as A vector upon mod of A. Okay. Here actually A means mod of A only, by the way. Okay. X, Y, Z are the components of that vector in the direction. So the result that we have is that cos square alpha plus cos square gamma plus cos square beta is how much? Can you recall? Is it 1 or 2?
1.
Okay. If you write this in terms of sign using the identity 1 minus c square is c square, you will have it as 2. Next, let's go to direction ratios. So direction ratios of a vector A is basically three components of any vector. We can see how direction cosines are unique of any vector in the direction
Yeah.
of a vector. Technically, if A is a vector, which is like say ax I cap plus ay j cap plus az k cap, then kx, kay, kaz, where k belongs to some positive real, are my direction ratios. Okay, why are we not taking any negative k? What would happen if we take a negative k, which is a negative scalar, negative quantity? Why can't we take that?
I mean, cost is more easily defined for positive values, right?
No, I'm asking here. I see. This is a vector. I'm taking these as a direction ratio, right? These would be your direction ratios. Why
Yeah.
k cannot be negative here?
I'm not sure.
See, the statement is three components of any vector in the direction of A.
Oh, yeah, then it won't be the direction. Okay, yeah.
Yes. it would be the opposite direction, 180 degree, anti-parallel, you can say.
Yeah.
Okay. Or you can say, okay, anti-parallel. Let's say you have to write direction ratios of a line parallel to a. Parallel to a. How do you write? K A X K A Y K A Z. You can take any K here, just that don't take 0. Now
Yeah.
you might be wondering, why are we now taking negative K's? Okay, also, do you think 0 comes here or not?
Okay.
Here.
No.
Okay, correct. So, see, I will define this, basically what happens in maths, parallel means either anti-parallel, you know, let's say anti-parallel, or they can even mean like parallel. So I will define this thing. So just this parallel thing you can know for now. Okay, direction ratios of a line through x1, y1, z1 and x2, y2, z2. So what you can do is write it as x2 minus x1, y2 minus y1, z2 minus z1. Or you can also write it as x1 minus x2, y2 minus y1, sorry, y1 minus y2, z2 minus z2, like that. Okay.
Yeah.
Okay, solve the question for me. If the projection of a line segment PQ on the axis are 3, 4, and 12, then what is the magnitude of PQ?
Okay, can you just repeat?
If the projection of a line segment
Mhm.
PQ on the axis are 3, 4, and 12, then what is the magnitude of PQ? Tech,
I
think
mean, is
how
this just the projection? Because then can we not? Then we won't be able to tell the magnitude, right?
oh, we can. See, projection is what? They're giving you like every dimension you would need.
Okay. Then it would be
What is
13.
13? Okay, you did 3
Magnitude.
square plus 4 square plus 12 square?
Yeah.
Correct. So basically what happens is length of projection are given, right? Length of projection is given. So you can take components, both signs. See, length is given. That means this could be plus minus 3, this could be plus minus 4, this could be plus minus 12. They are asking me this thing. Now, good thing that when we solve for this thing, it is just ax square plus ay square plus az square. So any one of I take, any one, I mean, any triplet I take, I get 13 only. Okay. Angle between two lines whose direction cosines L, M, N satisfy. L plus M plus N equals to 0 and L square minus M square plus N square equals to 0. So very standard questions. What happens here is you have to solve these. So you get like triplets of direction cosines. And most likely you will get two triplets so that you can find the angle between them. Okay. How would you find the angle between them? Let's say you have this line, you have this line. So obviously, whatever is the angle between their direction ratios, you can say. And for that, you can use cos theta, right? Cos theta is L1 dot L2 by mod of L1 upon mod of L2. If you have to take the acute angle, you can put mod here, right? Also, do you know how if there's like two lines, there's one angle over there, so another angle would be this, and this angle would be what? Pi minus theta. So, okay. Now how to solve these? So very easily, let's eliminate one of them. Let's say L is minus of m plus n. So m square plus n square. mm, okay, n is minus m. Is this correct?
Yeah, sorry, I was in mute. Yeah, I was trying to explain my own method. I don't know, but I don't think you could hear me.
Okay, can you try to complete this?
Yeah, no, I got it. I took n as minus L plus m, and then we get n equal to minus m, and for L plus m equal to 0, L equal to minus m, and then yeah, so the direction ratio is for L equal to when L is 0, it's 0, 1, and minus 1, and then for the second case, it's minus 1, 0, minus 1, 1, 0, and then so then we can just take cos theta, the formula, right? A1 plus A2 plus B2 plus B1 plus B2 plus C1 plus C2.
But
And then
tell
that'll be
me one.
1 by 2.
Okay, when we are taking, we have gotten this thing. When we put it here, it L would be 0. Okay, n is minus m, and m is m only. This is n. So we have 0, minus m, and m. So we can write that as 0, minus 1, 1. What about the other line?
Yeah, like I said, one is 0 wait, you took 0 minus 1 1. Okay, wait. I think because I was getting 0 1 minus 1 and then minus 1 0.
Students practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.